Well, hello and welcome to the 2021 Better Building Summer webinar series. In this series, we are profiling the best practices of Better Buildings Challenge and Better Plants program partners and other organizations that are working to improve energy efficiency of buildings and plants. My name is Bruce Long and I'll be your moderator for today. Just a quick introduction. I've been working in industrial energy efficiency since the late 1990s and more recently supporting the Advanced Manufacturing Office at the U.S. Department of Energy, particularly technical partnerships, energy management, CHP, and Better Plants. Today is the second part of our two-part series on combined heat power this summer. If you missed our first webinar on CHP and decarbonization, resiliency, and efficiency for industrial and commercial sectors, you can see its recording on the Better Building Solutions Center. It's either been posted or will be posted soon. Our webinar organizer will send out a link through the chat box for you to check it out. Today is more qualitative, and our speakers will go through some sample analyses of combined heat power systems. I'm going to introduce them in just a minute, but first, I'd like to go through some instructions on Slido. We're ready for that slide? Yes, okay. We are excited to announce that we'll be using this interactive platform called Slido for Q&A. And those of you who have been on our webinars before or through the summit, you've probably seen us use these before, so hopefully it'll be easy to use. Basically, all you have to do is just go to www.slido.com using your mobile device or by opening a new window in your internet browser. Today's event code is #DOE in capital letters. If you'd like to ask our panelists any questions, please submit them anytime throughout the presentation. We will be answering your questions near the end of the session. You can select the thumbs up icon for questions that you like, and this will result in the most popular questions moving to the top of the queue, and that means we'll get to them faster and better. Please reach out to our webinar organizers through GoToWebinar chat box if you run into any issues. And I think we'll go ahead and do a poll so far. Yes, we're going to start off with a few polls so we can learn about our audience. If you can please join us over at Slido to respond to the polls. Go ahead with the first one here. The first poll that we have for you today is, what manufacturing sector do you represent? And we're going to leave this open for about 30 seconds for y'all to chime in. So looks like we got some food processing. And, okay, good. Engineering, government, utilities, excellent. Keep on voting. A little multifamily, okay, universities, consultants, okay, good, excellent. We still have plenty of time left, so go ahead and keep entering your sector. Some pharmaceuticals, electrical equipment, cosmetics, very good, okay, keep on coming down. Water and wastewater treatment, excellent, okay. Trucking, we actually have one that's looking for work, so hopefully we can help them out today as well. Avionics, okay, good. We like to have an aerospace sector. Automotive, okay. We'll leave it open for just a few more seconds for everyone to chime in. I know we've got a pretty big audience today, about 100 people, so just want to make sure you all have enough time. Research, okay. All right. Excellent. Okay, we got 41 so far, so I think we'll go ahead and close it off right there. But thank you for joining. It looks like we have a pretty broad swath of the industrial and commercial sector. Our next question here is, what is your organization's experience with combined heat and power? Either you own or operate a system, you're evaluating it, you have not evaluated it, evaluated recently. Okay, more than 5 years ago. Okay, so a lot of you already have some CHP systems. Good. Looks like a lot of folks are now evaluating it for the future. Good, good. Okay. So it looks as though this webinar will be pretty informational for those of you that are going to be looking at it for possibly in the future. We'll give you a few more seconds. Okay, excellent. So I think we've got a decent number right there, and we can move on to the next poll real quick. We want to know what are the primary drivers or reasons for you exploring CHP at your facility. I guess this is particularly oriented towards folks who don't yet have the right. I believe this is going to be a word cloud. Yeah. Okay. Cost savings, heat recovery. Yep. Resilience. Okay, good. Energy efficiency is a big driver. Biogas utilization. Okay. Good. Okay. So far, it looks as though energy efficiency is the big reason for a lot of folks. Also, some compliance drivers. Interesting. Okay. Power generation, definitely. Okay. We'll give folks a few more seconds here. See if we can get up to 40. All right. 36. Grid independence. Okay. Excellent. Very good. Recovery. Excellent. Okay. Yeah, these are really good reasons. I think our speakers will definitely look through these and work them into their presentations a little later on. It looks as though we've kind of reached perhaps a maximum here, so I think we'll go ahead and close this one off. But thank you for responding. I think our last one here is: are you familiar with the Department of Energy's CHP Technical Assistance Program and the technical assistance services that they offer? Oh, okay. So go ahead. For those of you who are unsure, I will say that the CHP TAP program has gone through a few name changes. So you may have known them when they were, I think, the regional application centers. Okay, good. We're getting up to almost 40 so far. It looks as though a lot of you are not familiar with the TAPs, so I think this will be a good webinar for you to understand all the things that they can do and how they can help you. Okay, there's a few more seconds. I think we're pretty much almost there. Okay. Well, I think this probably gives us a good idea right there. I don't know if anyone else wants to jump in one more time. Yes. Okay. No. Okay. Well, I think we can probably close it off there. Thank you very much for participating in these polls. So basically, what I'm going to do now is introduce both of our speakers, and then they'll take it from there. Our one speaker, who is from the Technical Assistance Partnership that's part of the University of Chicago, is Cliff Haefke. Cliff has over 20 years of experience in the energy industry, and he is the director of Energy Resources Center at the University of Illinois Chicago. The ERC is an interdisciplinary public service research and special projects organization that strives to improve energy efficiency and the environment, providing expertise in the area of energy efficiency, distributed generation, combined heat and power, bioenergy, sustainable transportation, utility data analytics, and sustainable landscapes. As director of the ERC, Cliff oversees the center's strategic direction. He has overseen the securement of over $30 million in new research funds. He serves as the director of the US DOE's Midwest and Central Combined Heat and Power Technical Assistance Partnership, and he also serves as an assistant director in the UIC's DOE Industrial Assessment Center. Also with us today is Bruce Hedman. Bruce is the head of Entropy Research, is a senior advisor to DOE's Combined Heat and Power Deployment Program, and serves as the coordinator for DOE's Packaged CHP Accelerator. Bruce Hedman has over 40 years of experience in industrial energy technology research, development, and commercialization, including with combined heat and power and distributed generation technologies and markets. As a reminder, please send in your questions through Slido, and by going to slido.com and type it in the event code #DOE. and we'll try to get to them as soon as we can. The session will be archived and posted to the Building Solutions Center for your reference. And with that, I'm going to pass things off to Cliff to begin the presentations. Thank you all for joining, and we thank you ahead of time for staying to the end of the presentation. Cliff?
Great. Thank you, Bruce, for the introduction. It's a pleasure to be with you all today. I guess I should have had a name Bruce, right? You would have had 3 Bruces here. So I've never presented with 2 Bruces, but excited to be here with on this Better Buildings webinar. So here's the agenda that Bruce Hedman and I will cover. I'm going to give a quick overview of the DOE CHP TAP program. And for those who are not familiar, we saw from that survey, hopefully that'll be some insight into our program. A quick overview of the CHP basics and benefits. And then really is what I want to dive into in more depth are those next few bullets, the project development process for CHP systems. And then showing you, if you're going to work with the DOE CHP TAPs, a no-cost service, is what do our projects look like? The screening analyses, what do those look like, and how will that interaction occur? We'll show then some of the follow-on technical assistance that we do provide, which we call advanced technical assistance. We'll give some examples there. And then Bruce Hedman will then end the webinar, or carry on the webinar, with showing how are we calculating emission savings from CHP and providing some perspectives there. Next. So this is what we're going to look at. How do CHP projects fit into your goals? And we know they got to be tailored for the different facilities, but you already saw here is what I will be covering. So next slide. So here I want to give a brief overview of our CHP Technical Assistance Partnerships, or as we call TAPs. One is, here's the three objectives that we have. One is working with end users to provide them education, the concepts, the benefits, and opportunities that CHP can provide them. Next is we work with stakeholders, such as regulators, utilities, policymakers, again, to provide education, but how CHP can be part of the larger energy solution, whether it's at a city level, state level, a regional level, and even a national level. And third is what we'll be diving in today on is the technical assistance services, where our team members of our various CHP TAPs provide one-on-one technical services to evaluate CHP at specific facilities. Next. Here is the map of our nation, right? So we have 10 regional centers. You can see them by the color-coded regions. Just for perspective, I'm located in the Chicago area at the University of Illinois, Chicago. My team does manage the 2 green centers, the 2 TAPs there, the darker green and light green. And on the different boxes and bubbles, you can see the contact information from all the different TAPs. And following this presentation, you'll be receiving a copy where you can get the contact information for each of our TAP directors. Next. So on this slide, what I really want to do is take you to that graphic in the middle there, the project flow diagram for CHP projects. I'll start right away that a CHP system is usually not your quick replacement, your quick installation. So CHP is comprehensive. There are many facets. We're working with a variety of forms of energy, fuels, looking at the electric side, the thermal side, several components that are brought in here, different size systems. So, CHP projects can take months to even, we've seen several years of implementation depending on the complexity. So this is what we want to look at to help a client work through this process and start from the beginning. Let's screen a facility. Let's do a preliminary analysis before jumping into a feasibility analysis or investment grade analysis. Let's get some of those basic concepts flushed out. Let's see what kind of what's happening at your facility. And we like to do that at the very beginning before embarking on and putting too many resources of both our side and even a client side into this too. So you can see, starting with the screening and preliminary analysis, if that looks like there's an opportunity at that site for CHP, we typically recommend a feasibility study. Most often then if the feasibility study has favorable results and we want to look at securing the financing for the project, then we're going to go towards an investment grade analysis. If the project looks great at that time, then we're putting a project in, we're procuring it, we're operating it, maintaining and commissioning. And the text boxes in the bottom there show where our DOE CHP taps integrate within the project development process, pretty heavily in the upfront portions. And then hopefully by the feasibility study, investment grade analysis, you're working with the private sector. But we're also working as advisors. We are providing technical reviews. We are helping with calculations or other types of activities, but just being a sounding board and helping a client hold their hands through a CHP project as it moves on towards development. Next. So combined heat and power, if you attended the last session, apologize for this slide, you probably saw this, but just a quick recap. Combined heat and power, or CHP, is a form of distributed generation located at a site or a building. It's an integrated system, provides at least a portion of electric load, and the key aspect there is heat recovery. Can we utilize the thermal energy from the CHP prime mover to generate heat, cooling, or even dehumidification? Next. Combined heat and power, the big advantage here, and we saw that from your answers, from the survey results in Slido, is energy efficiency is one of the key aspects of this. So when you have the high efficiencies, that's hopefully translating to lower operating costs, right? Reducing the operating costs of your facility, one of the big keys. But also with efficiencies, you are hopefully getting reduced emissions as well when you're taking it back to the source energy. So that's the aspects with energy efficiency. And another aspect of CHP that we're seeing more and more traction with is the resiliency that it can provide a facility. If the grid goes down, we are seeing CHP systems maintain operation of their facilities and plants. It adds an extra level of reliability, which is a growing concern of many folks, many facilities in the manufacturing sector, critical infrastructure, and others. And also CHP, when you have reliable fuels, you can also provide help to the grid in terms of grid congestion and avoiding distribution costs. Next slide, please. So now this is where I'm trying to get to the meat of my presentation. This is where it starts here, is when we're looking for a CHP project, a candidate site, what do we need? What are the conditions? What are we, as CHP taps, what are we looking for, and how, why, and when would it make sense at the facility? So we've kind of grouped this into 4 different categories. First is the necessary conditions. 1, are you using electricity? But right away, at the same time, do you also have coincidental thermal loads at your facility? It's very important that you're using both electricity and thermal energy at the same time. And do you have high hours of operation? The longer you can run the CHP system, the better your return on investment usually can be. So you want to have that system running as often as you can. Second, when should you look for when should you consider CHP at your facility? And here's a few examples. It's when you have a facility that's looking to replace energy equipment. We'll start with the first one. If you have backup generators, they're aging, you're looking to replace them. Instead of replacing your backup generator with another backup generator, why not look at a CHP system that's continuously running, that you know it's going to be up and running, may have a higher incremental cost, but as you are running, you are also recouping on your investment, your return on your investment. You're getting your savings, and you're not getting your savings on a backup generator unless there is an outage. So here you can look at those opportunities. With a chiller, again, if you're looking to replace a chiller, instead of replacing an electric chiller for another electric chiller, why not look at a steam fire chiller that's coupled with the CHP system? And then also you'll have an electric generating asset. Again, there would be an incremental cost to that, but what are the long-term benefits and impacts? And often we see when entities, many manufacturing plants are looking to replace a boiler, you're generating hot water or steam. And instead of just replacing a one-for-one boiler, again, look at the CHP opportunity. There will be an incremental cost, but oftentimes you can cover the thermal needs that were needed at your facility with the CHP system. And now you've added the added benefits of generating electricity on site for additional energy savings, but also beefing up your resiliency aspects at your facility. That third, the customer motivation, that's kind of the why. What is the drivers there? What's really driving the facility to look at combined heat and power? And to have someone that's going to champion this project at a facility too. Are utility costs the primary driver? Are they looking at reliability concerns? Do they maybe have waste heat coming off an industrial process that maybe they can capture and generate electricity with? Or do they have biofuel resources on site or nearby? Maybe there's an anaerobic digester for treating food waste. Maybe they have biogas available on site. Maybe there are nearby facilities that maybe have biomass or other organic substrates that could be used as fuels eventually. Are there sustainability or environmental goals for a facility? We're seeing that as a increased driver and motivator as well. And we're seeing that built into the sustainability plans, where we're seeing sometimes CHP has a bigger impact than several other projects, and not just impacting today, but also into the future. And also expanding. When there's expansions at a facility, maybe you're adding on another process load at your facility, another process is coming online. How will those energy needs be met? And that's where CHP can have a play in there. Instead of putting in another boiler or another chiller, why not look at a combined heat and power system? At least take the time to evaluate the costs there and the benefits if you're planning early in the stages here. And finally, the other factors is when we come to a facility and they're looking at CHP, we want to make sure there are some other activities in place. Have they already implemented maybe low-hanging fruit, other energy efficiency measures that we are sizing a CHP system to the right size? And also, it's not impossible, but it does help when a facility has a centralized heating and or cooling system, so the project can be more easily tied into the existing cooling and heating system. So again, when we're looking for ideal conditions at a site for potential CHP opportunities, these are the items that we recommend you looking for, and these are the conditions that we are looking for as also we're trying to qualify CHP projects. Next. So once a site is qualified, and that's one of our roles as a TAP to help qualify these facilities, hopefully we can be your first stop, when you're looking into this, when you're exploring. Again, the services, the DOE CHP TAPs are no cost. And this is our first step here. It's a quantitative and a qualitative analysis here where we are taking high-level data, we're having a conversation with the facility, we're trying to understand what the client needs are, what their concerns are, and we're trying to piece things together here. We're also going to help identify if there's red flags. We want to minimize the resources put in on both sides. We don't want a client to put in too much time if we can identify maybe some of the red flags early on. But hopefully more often than not, there are more green flags than red flags, and we're recommending you to move on to a feasibility study. So this would, the outcome of this is really to advise a client to further pursue the investigation of CHP. We will not be giving the investment grade decision at this point, but more so providing guidance to the client, sharing that, hey, CHP looks like it makes sense. You got to do a more deeper dive after this, but here we have some good numbers and we will walk you through this. Okay, next slide. So as we're going about the screening process, these are the steps that we typically walk through. You can see them here, but I'm going to talk about them slide by slide. So next slide, please. I apologize for all the text on the screen here, but this is our first step with when we're looking at a screening analysis is that initial conversation with a client. Our TAP, it's usually about an hour conversation or so. It could be shorter. But here we're trying to flush out, an understanding of the facility. A lot of the questions you're seeing on the screen here, I already covered a few slides ago when I was talking about the ideal conditions and what we're looking for. But again, we're trying to understand what is occurring at the facility. What energy projects have they already done? What are the motivations? And understanding the particulars. So sometimes we are sending this questionnaire beforehand, we're getting the answers back, or it's just part of the discussion. And we're having this discussion with a client, and we're walking through these questions, and again, trying to understand how does CHP fit into the mix, and what are the real drivers from that facility, why they're looking at CHP. Next slide. Next, it's the fun part here. Hopefully we're collecting data. And again, the more data we can collect, the better solution we can provide. I'll also say too, though, at times we have limited data, and then we're making assumptions, but we are agreeing with the client what those assumptions are to try to get an answer. Maybe we're making projections on what a future load might be that's added onto a facility. Maybe it's a green site and we just have very minimal ballpark numbers, but we're going to get you an answer somehow. But you can see on the right of what we're looking for. On the electric side, we're looking for electric consumption, kWh. We're also looking at that the demand rates. We also might take a look at your utility rates. If CHP is implemented, how does that impact some of the costs? On the thermal side, oftentimes we don't have as much information, but we're trying to get what we can there. Is there steam at the facility? Is there hot water? If there's steam, what pressure? Are there pressure drops at the site? What are the flow rates? What is the condensate return temperature? We're trying to collect as much information so we can feed you a better result. Maybe some of that thermal data is also chilled water. So we're looking at all aspects here. We want to look at your natural gas bills, and then also get an idea of your site characteristics. So hours of operation, where is space available on site there? You can see the graphs on the left there. The top is the thermal, the bottom is the electrical. And you can see there maybe is a little mismatch of how the energy loads are during the year and trying to get the same energy loads for a CHP system. This is a chemical facility, but there are some seasonal demands occurring here. So on the thermal side, you can see the winter months have more thermal energy. Electric side, the summer months have higher energy. So with our analyses, we try to get the best match CHP system for you. Next slide. So here, once we have the energy data, now we're sizing the system. On the top, those are load duration curves. So here we're taking the hourly interval data, and we're taking on the left-hand side is electric demand. We're taking the highest electric demands, pushing them to the left, and the lowest electric demands to the right. So you can see this facility peaks at about 5 megawatts, and it drops down to about 1 megawatt all the way to the right. That dotted yellow line there, we've kind of estimated a 3.2 megawatt CHP system. And if you were to take the intersection of those two lines, the blue and the dotted yellow, drop it down, you're somewhere around, I guess, the 9-month frame here in the x-axis. I apologize, this should have been in hours, like the graphic on the right, but we put the wrong graphic in here. But you can see that 3.2 megawatts would cover a site's energy load for 75% of the time, and then the rest of 25% we'd be over generating. So that's not too bad of a match there. And on the right-hand side, we're doing the same thing for the thermal demand. We've taken the site steam demand. On the left-hand side of the blue there, it's almost 40,000 pounds per hour for 125 PSI. And you can see to the right, there is a plant shutdown there where basically we're not using any steam. That dotted yellow line shows 20,000 pounds per hour of steam generation with a turbine that's unfired. If we're firing it, this system could provide up to 30,000 pounds per hour. So now we're starting to match up, what specific CHP system can we match up for your facility? Again, at a high level estimate. Next slide. So once the system is, or we're looking at the sizing of the systems, we do at times look at the CHP technology. Sometimes at some levels, we don't have to worry too much about what CHP technology we're looking at. But yeah, if there's a high pressure steam at the facility. We're probably going to look at a combustion turbine. But you know, it depends from system to system. And here you can see a graphic of different size systems. If there's a lot of steam at a site, we may look at a steam turbine or a back pressure steam turbine. What I also want to highlight there at the bottom is the Department of Energy has produced the CHP technology fact sheets. And in there, all our taps are using the same numbers. We're looking at the same specs. We're using average specs that were grabbed from the industry. We're looking at average cost and average O&M cost. So we're trying to use some unified information as we are working between all 10 taps as we're trying to provide solutions for a number of different clients. Next slide. So once the facility or the CHP system is sized, then we're starting to look at the results here. What are we coming out with here? And now I'm jumping to another type of facility. It's a paper mill, a paper facility, a little bit larger. Here on the top, you're seeing the CHP system specs. This is a 32 megawatt CHP system. A 31,963 is what our model put out, generating over 130,000 pounds per hour of 240 psi G steam. So that is the size of our system. And then when you look at the lower part of this slide here, you see the base case versus the CHP case. Right away, I'm going to draw your attention to the purchased electricity, that first line. In the base case, we're purchasing 280 million kilowatt hours from the grid. Now, when the CHP system is installed, we're purchasing a lot less than the grid, about 5.5 million kilowatt hours from the grid, because we're generating over 274 million kilowatt hours. You could see maybe 5 rows down the boiler fuel consumption. So that's drastically reduced. But you look at the bottom line, there is we are consuming more fuel, okay? But oftentimes we want to compare that to what was the source energy, what was being consumed at the grid level. And the right-hand side, you could see the efficiency. So over the 87, 60 hours of operation over the year, this CHP system would have been operating at a 75% efficient. So using the fuel, generating electricity, recovering heat, and having an efficiency of 75%. So a very high efficiency here when we're comparing it to our separate use of energy. Next slide. And then we're looking at the economic results. So remember, this is a screening analysis. It's a first cut analysis to see if there is potential for a CHP project. And oftentimes that next step is a recommendation towards a feasibility study. There could be something in between there. But looking at here, again, looking at the purchased electricity, we purchased a lot of electricity. We're paying for a lot of electricity in that base case, that left side, $16 million. Where the CHP case, now we're spending less than $2 million for purchased electricity because we're generating so much. In the boiler case, we were using $4.8 million to generate thermal energy. Now in the CHP case, we're only using $333,000 for boiler fuel. But here's the, I wish I could stop there, but we do have fuel for the CHP system, $8.5 million. We got to make sure we account for O&M, incremental O&M, about $2.5 million. But you can see there's still operating savings of nearly $7.5 million for this project. Now jumping to the lower part of this slide, you can see for a size system like this, average cost might be around $47 million. Our CHP taps look at grant incentives, utility incentives, investment tax credits. What can we take advantage of to help lower that first installed cost? Here we're taking advantage of the ITC, the investment tax credit, and we're having a total cost of $42 million. Do the math there, $42 million, $7.5 million in annual operating savings. We have a payback about 5.7 years. That's pretty decent for a CHP project of this size. Remember all the benefits that come into play. Next slide. So the screening analysis is completed, it's delivered to the client, and we look at what are the qualifying opportunities. Again, what were the primary drivers of the facility and the site? And we look through that list and we talk with the client there. We might massage some of the numbers. We might add in some other scenarios, but we're trying to see if does this qualify. And then we're looking at the next steps. Sometimes it's a feasibility study, or maybe there are some additional activities that we suggest that occur, and I'm going to walk through those on the next slide here. Next slide, please. So here's a list of some of our advanced technical assistance. You can read in the screen there. They're all over the place. It could be a 15-minute performance model. Maybe a site needs a performa, again, at a high level to understand this. Maybe it's a greenhouse gas emissions analysis. Bruce is going to cover some of that. Maybe it's looking at how the standby rates are impacted. There's so many other aspects that we could be looking at. If we're further down the road and maybe a feasibility study is completed, our CHP tabs help review studies. We've reviewed bids before. We've helped clients develop an RFP. Again, we're trying to help hold the hand of a CHP project because these can take quite some time. They can take months, sometimes even years to implement, from initial conception to all the way to implementation. Next slide. So now I'm going to step through some specific examples, and I'll be turning it over to Bruce shortly here. These are just some examples from our Midwest region. Other taps from different regions have other stories. I'm just sharing the Midwest flavor here. This is Benton Harbor, St. Joseph wastewater treatment plant in Michigan. We met with them a year or two ago. We started with an IAC assessment, another DOE program. Then we did a CHP screening. They wanted to use the biogas at their site for CHP. We helped them with some of the biogas analysis. And this year they implemented a CHP project. So a great success story of a wastewater treatment plant that worked through various programs of the Department of Energy. Next slide. So this is Gunderson Health. They were the first hospital in the United States to reach 100% energy independence. And our CHP TAP had the opportunity to work with them in a couple projects. The one shown there is a landfill gas fueled CHP project where they partnered with the county, piped the landfill gas 2 miles to the hospital, and now they're using CHP with absorption chilling there. Our team helped with the landfill gas calculations, helped with the RFP development, and also helped review the applications there. It's a great project there. And another project we helped there too was with their woody biomass project that was completed a couple years later. Next slide. A recent activity of ours, we worked with Illinois Wesleyan University. They needed more details. So we provided a hourly performance analysis. We helped with the performa, and this all helped feed into a feasibility study that they later had implemented that was funded by the natural gas utility. They did put an RFP out for this one this spring, and I think they are securing their engineering company to do further analysis for them. So again, the various ways that we have helped in the past. Next slide. Here's just an example of we did an hourly performance analysis, but then we also completed a performa. So this has a turbine in here, return on an equity of 19.3%, net present value of $6.4 million, and a simple payback of 4.5 years. So this facility, a serial manufacturer, simple payback wasn't enough. They needed to see what that looked like. So this is where we help tailor that solution to them. And then next, on my final slide, is kind of a segue into Bruce's discussion here, talking about emissions reduction. And this site, a paper mill in Wisconsin, not only wanted to know what the emissions impact of CHP were today, but we're now projecting out 10, 20 years. And this is what we feel we might be doing more analyses like this in the future. So that I'm going to take you to that graphic there. That red line is showing if there are no new energy policies, and we're staying as is. The blue line is showing if we, by 2050, if we have only CO2 emissions from natural gas peaking plants, and that green is if we go carbon-free generation on the grid by 2050. So you can see it's all about the carbon emissions impacts, so CO2 emissions impacts of a CHP system. And you can see projected out, no new energy policies. There's still a lot of impact when it's just the marginal generation is natural gas. We still have impact. What you can see is green, there's less impact, but again, this is for a natural gas-fired system. But over time, these could also be converted over with renewable natural gas and hydrogen and other fuels. So I'm going to leave the rest of the carbon emissions discussion to Bruce. Thank you for your time and looking forward to the Q&A.
That was a great intro into what I'm going to be talking about. I want to spend the last 10 minutes really walking through the basics of calculating the emissions and energy impacts of CHP. And as Cliff talked about, this is an area where we're getting a lot more inquiries about what are the emissions impacts of CHP. We're getting it from facilities that are exploring or evaluating CHP to be part of their sustainability plans, and we're getting it from other stakeholders that are wondering if that fossil fueled CHP that's in their area is really saving any energy and emissions at this point, and is it helping? So what I'm going to do is walk through the process of how we evaluate the emissions and energy savings of CHP at a fairly high level, and end with pointing you to some resources that will walk you through it and help you implement these kind of analysis on your own. So in this slide here, I'm going to start really with a slide I used in the previous CHP Part 1 webinar, where we sort of explored the role of CHP in the path to decarbonization. Can CHP be part of a long-term solution? And we do think there is an important role for CHP in decarbonizing the U.S. economy and U.S. industry. I think first, it's really important to note that CHP is fuel flexible. Current CHP systems use renewable fuels, they use low carbon waste fuels, hydrogen blends where available, and all these systems will be ready to use higher levels of biogas, renewable natural gas, and hydrogen in the future. All the major manufacturers now offer equipment, gas turbines and recip engines that can run on anywhere from 10 to 40% hydrogen mixture, and all are working to introduce 100% hydrogen systems in the near future, 2030, for that market if it develops. And there's long experience on non-fossil fuels. If you look at the industrial CHP capacity that's out there, 15% of that capacity is fueled by non-fossil fuels, biogas, wood, other biomass. But in terms of the number of units, installations out there, over 40% of the current industrial systems operate on non-fossil fuels. So there's a lot of experience, both from the equipment suppliers and end users, in using non-fossil fuels on CHP, and it is a very flexible technology. Second, and Cliff talked about this too, CHP is the most efficient way to generate power and thermal energy from a combustion point of view. And for the long term, renewable and hydrogen fueled CHP, we think, can be a cost-effective path to decarbonize thermal end uses in industrial and commercial facilities that are difficult or very expensive to electrify. This could be a more cost-effective path to get those CO2 savings. And also, we see the need for renewable and hydrogen fueled CHP to support critical facilities that need to decarbonize, but also need on-site power, dispatchable on-site power for long duration resilience and operational reliability. And as the natural gas infrastructure converts to renewable hydrogen fuels, if it does that over time, the high efficiency of CHP will be able to extend those resources as they come on. So we think these are all important points for CHP being a part of the solution. The next slide really gets us into the discussion of walking through at a high level how you estimate the fuel and CO2 emission savings for CHP. And don't worry, I'm not going to go through all these numbers. We'll be able to do that when the slides are posted, but I'm going to try and walk through the process at a high level. And I'm basing the discussion on this 20 megawatt gas turbine CHP system, natural gas fueled. It's very typical of what you would find in an industrial application. It operates at 90% annual load factor, capacity factor. It's 7,800 hours per year. It has a net electric efficiency of just over 33%. 75 million BTUs per hour of steam output. And it's a well-designed system, so it is using all the steam output. It's not wasting any of its output. And that displaces the output from an 80% efficient natural gas boiler. So that's sort of the basics of this. And you can see from this chart on the right, the amount of fuel that it takes to supply those thermal needs, electric and thermal needs to this site with separate heat and power. You can see the fuel going into the power plant, the fuel going into the on-site boiler, and that supplies these energy services at a total 53% efficiency. CHP system on the right supplies these services at a 70% overall efficiency using much less fuel. You can see over 500,000 million BTU per year of less fuel going into the CHP system, resulting in a significant CO2 savings of 70,000 tons per year for this plant. So this is the basic emissions and energy value of CHP. Next slide, please. So how do you go through the calculation for all this? How are these savings calculated? And there are two overarching things to remember, and I think I put these upside down. But the first is that both electric and thermal outputs of CHP must be considered when you're looking at the savings of energy and efficiency. And key is that the effect of CHP on the grid, the fact that you are no longer buying megawatt hours from the grid, it's very similar to the load reductions from an energy efficiency or renewable energy project or program. And it's essentially the marginal generation on that grid, that power control area that you're in, is what you're displacing. I'll go into that a little bit more. The approach for calculating emissions reductions is pretty simple. It's basically arithmetic. It's the emissions and energy impacts of CHP are calculated by subtracting the emissions from and the energy used in the CHP system from the sum of the displaced grid emissions, what you no longer is being used at the grid to energy and emissions to send kilowatt hours to the plant, plus the avoided boiler emissions, the emissions reduced and the fuel reduced at the boiler because you're now supplying steam from the CHP system. So it is pretty basic. It's pretty straightforward, but like most things, it's really in the details that can be difficult. And what are the correct basic assumptions? Where can I get the data I need to do this? Those are really the key issues. Next slide, please. And just for the easy part, the CHP emissions, the CHP fuel use, the displaced boiler emissions and fuel use are very simple, very easy. It's a function of efficiency and fuel of each technology, the CHP system and the boiler. The efficiency will vary by technology, system size, and fuel type. But all that information is readily available. The CHP TAPS have it. We can help you out from headquarters as well. And if there's one key thing to remember is that for estimating the displaced emissions and fuel for the boiler, only the thermal energy that is used can be counted. Sometimes you can recover more thermal energy from the CHP system than you actually use on site. You got to use you got to base a calculation on what's used on site. Next slide. The more complicated part is how do you estimate the displaced grid emissions and energy use from the power grid? The EPA has provided guidance for how to do this. They did this 10 years ago as part of their guidance for state implementation plans for energy efficiency, renewable energy, and CHP projects. And their guidance was basically that a new project, a new CHP project, a new energy efficiency project or program is really going to displace the marginal emissions on a system. It's not going to displace the average, all-in average emissions. It's sort of displacing what's on the margin at that system. And I put these two curves here just sort of to demonstrate in a sort of a cartoonish way how that impact is looked at. But these are basically low duration curves, typical of a power control area. You've got the megawatt demand going up the y-axis, the hours per year, or the number of hours that each resource is operating on the x-axis. And that low duration curve is the curve of the demand of the utility or the control area. When you put an energy efficiency project in or a CHP project, this is greatly exaggerated on the chart on the right, but it brings that whole curve down, particularly if it's a base load kind of system like CHP very often is. And you can see that dropping down a load curve hardly ever gets into cutting back on wind and solar and nuclear and hydro. It's the gas and oil peakers, it's the intermediate gas and oil and the coal and combined cycle gas that gets shed as part of the marginal generation. If you go to the next slide. So how do you estimate what the displaced emissions are from that mix of marginal generation? And EPA has helped us out here. They've developed several tools to do that. But if you look at the chart on the right, there's a continuum on how you do it. The most correct way and most accurate way is to do energy modeling, dispatch modeling of the area you're in and what the impact would be of that project. But that's expensive. It takes a lot of time, and no one's going to do that. So EPA has developed two estimates of marginal emissions by region in the U.S. One is very basic and was introduced first, and that's the Emissions and Generation Resource Integrated Database, or EGRID. And then there's a newer one that came, it's 10 years old now, but it came out after EGRID, called AVERT, the Avoided Emissions and Generation Tool, which uses a little bit more of a sophisticated approach to estimate what the marginal emissions are on a regional basis. And I'll talk very briefly about the two of those, but you can see on the table on the right a little bit of a comparison of EGRID and AVERT. AVERT has less regions. EGRID has a little bit more granularity on the regions. Also includes Alaska, Hawaii, and Puerto Rico. AVERT is only limited to the continental U.S. But if we go to the next slide, this is looking at more closely at AVERT. And right now, you'll see this in a second, but EPA has a methodology report that talks about how to calculate emissions and fuel savings for CHP. A new version is just out. In that version, they are recommending first AVERT as the first resource to go to. I think they view the marginal emissions estimate in AVERT to be a little bit more sophisticated than in the EGRID one. But there are some limitations, as I talked about. The regional granularity is only for mainland US. It only has 14 regions compared to 27 for EGRID. As an example, in EGRID, New York is split into 3 regions: upstate, Westchester, New York City, and Long Island, and they have very different emissions profiles for marginal generation. So there are some cases where you might want to use EGRID over AVERT. Next slide, please. So I'm going to try and get through this pretty quickly. I ate up some of my time by not being able to talk. But going back to our original look of this system, again, I'm not going to go through the numbers, but now you can see some of the assumptions that were used to come up with these numbers. Natural gas fuel is for CHP in the boiler, produces 16.9 pounds of CO2 per million BTU. You multiply that number times the BTUs going into both the boiler and the combined heat and power box here, and you come up with the tons of CO2 that you see in the chart. The marginal grid emissions for nationally from AVERT for what we're talking about for CHP is 1,550 pounds CO2 per megawatt hour. Multiply that by the megawatt hours produced by the power plant, and you get the 122,000 tons per year of CO2 emitted by the power plant up above. So again, you'll be able to look at, walk through this when you do get the slides after this. And the next slide, please, is the good news. I talked about this. EPA does have a very detailed discussion of the methodology and assumptions, default assumptions to use to do this calculation. There's a website and the download for the report itself. And on the next slide, even better news is that EPA also has a fuel and emissions calculator tool. It has recently been updated. It will walk you through the process of inputting the data that's required to do this, picking the assumptions that make sense for your project, and it will present the results as you see on the right here. And the numbers are very close to what I did by hand in the other two slides. They're sort of off due to rounding and things like that. But this is a very useful tool, and it'll walk you through the process. And again, if you want any assistance in understanding this calculation process, these tools are the resources I talked about. My contact information will be at the end of this the deck. And the CHP TAFs are also very familiar with this and use this on a daily basis and can help you out on each of the regions. Very quickly, a final slide. And again, I'll just, applying this methodology to a 20 megawatt natural gas CHP system, as you see here, results in 70,815 annual tons of CO2 savings. That's the calculation that has sort of been what I went before. If that was a biogas CHP system, displacing a natural gas boiler, that savings increases to 165,000 tons. And I put down 20 megawatts of utility solar PV and utility wind in comparison. Not to say CHP is better, because just to show that CHP can provide about the same order of magnitude of CO2 savings as these renewable technologies. And it's not because it's creating the same kind of savings per megawatt hour, but because it runs at an annual capacity factor of 90% versus 24% on an average, national average for utility solar and 34 for wind. You can get a lot more bang out of that 20 megawatt of capacity in natural gas or biogas CHP at this point. So there is a role for high efficiency CHP in reducing CO2 emissions, in reducing energy, and with renewable and hydrogen fuels in the future, I think that role will continue and will be more important. With that, we can go into questions and answers. If we have any time left, I apologize.
Thanks a lot, Bruce. That was very insightful, and I think because of the technical difficulties, we'll probably extend the time of the presentation a little bit. At this time, we would like to start taking your questions, so let's transition over to Slido. So if natural gas is my fuel, is any portion of the power output, heat reused, or efficiency gained considered carbon-free? Either Cliff or Bruce Hedman, feel free to take that one.
Bruce, you want to go first?
I don't know if you would call it carbon-free. I think hopefully the numbers demonstrated that you do provide carbon savings, CO2 savings. You are not a carbon-free technology. That's certainly not. But over time, as we move to a completely decarbonized grid, and if you assume that part of that way of getting there is also a decarbonization of the 2.5 million mile pipeline infrastructure, and those fuels that CHP systems are using are low to zero carbon, then you won't have any carbon coming out of it, basically, or what carbon is coming out of it is renewable and is part of the cycle.
Yeah, and I'm going to add to that too. I agree with Bruce there. Maybe looking at some of the state nuances, how they qualify renewable energy technologies. Sometimes we've seen where recovered heat is a qualifying what is it? I guess technology or concept. It could be some loopholes. I don't want to say loopholes, but some nuances there to explore in some states where recovered heat is eligible as a renewable fuel, and sometimes that can qualify if you really dig into it. But again, state to state, and just an additional thought there.
Very good, thank you. The next question that has the highest number of likes, I'm not sure how we can really answer this, but can you describe if a CHP system can replace chillers?
Yeah, I'll take a stab at that. Maybe that's how I presented it. When you're looking at your facility and you have electric chillers there, and you're looking to upgrade those or update them with new chillers, the concept there is, you could just replace one for one, an electric chiller with an electric chiller, or you could explore a CHP system where the recovered heat from your system is not going for actual heating loads, but you're taking that either recovered heat, you're generating hot water, or you're generating steam, and then you're putting that steam or hot water through a steam-fired chiller or a hot water absorption chiller or some kind of absorption chiller. So it's taking another way of generating electricity versus just with an electric generating chiller. So you do that, and then you also have an opportunity to have electricity being generated in your site too with that CHP system.
Okay, thanks a lot, Cliff. The next one I think is actually a really good one. Do you have any resources for supporting combined heat and power after installation? This speaker said that they found the first year success was good, but then enthusiasm slips after that. And that is an ongoing kind of question about how do you maintain a CHP system when there's advances in computerized technologies, control systems, electronics, and that kind of thing. So.
Yeah, I'll take a shot at that, and then Bruce, maybe if you want to add on to there. I would say contact one of the CHP taps. The CHP taps are plugged into the community there, so you can bounce some ideas, thoughts, off the CHP tap representatives. But there are also trade organizations out there too, and associations where there are a number of folks that do the maintenance of these systems. So I would say first stop is work with the tap, and they might be able to direct you in a certain direction. But then there's also a larger CHP community that can help with this, and staying plugged into resources like this, the Better Buildings webinars, and other webinars such as those from the e-catalog that can provide some updates on there too. Bruce, I don't know if you have anything else to add on the systems after they're installed, who to plug into.
No, I think you covered it, but we have had examples where folks have come to the taps and had some problems with their systems and just wanted to have a third party take a look and see if they had any suggestions or assistance they could provide. So it is part and parcel of the job, I think. Yeah,
I agree. And actually, also, if you're in the Better Plants program, you can also lean on your technical account manager. A lot of them have experience and understanding of CHP systems and how to maintain combustion technologies and stuff like that. So the next question we have is, do you have examples of small combined heat and power projects? So the person says, as an example, use a facility that generates heat from product testing that is currently wasted. You'd like to use it for HVAC or other processes.
Yeah. This example sounds a little bit more like recovering heat and then using it to, sort of like a waste heat to power or waste heat to chiller or something example. And there are a number of small ORC systems out there that you could look at, and Heat is Power is a trade organization for waste, ORCs and waste heat that you might look at. But there are all sorts of examples of small traditional CHP projects, engines, microturbines, providing 24, 15 kilowatts of power to a site and hot water. And one of the resources DOE has put together is a packaged CHP electronic catalog, packaged CHP e-catalog. It has package systems that have been sort of vetted or reviewed by CHP and packagers and solution providers that range right now, I think, from 24 kilowatts up to 16 megawatts in in this electronic catalog, and our 270 system offerings, and you could get a really good feel for what kind of equipment is available at the lower size range from browsing through that e-catalog. And I think if you just Google DOE package CHP e-catalog, it should pop up pretty quickly when you do that.
Okay.
Yeah, I was going to say. Oh, yeah, I was going to say the same.
Go ahead, Cliff.
About the e-catalog. It's a great resource looking at technologies, and if any of you are interested in looking at what is already out installed there, the Department of Energy has also created a nice database where they try to keep track of all known CHP systems around the country. You can navigate by state, downloadable spreadsheet. You can see what system sizes, fuel types, year installed, site name, et cetera, a number of installations out there. And that one, if you Google DOE CHP installation database, you'll be able to get the thousands of CHP systems there. So great resource as well.
Thanks, Cliff. I think we're going to take one last question, and the question here is, does the TAP cover hydrogen fuel cells? But my sense is that, you know, it might be better to redirect the question a little bit and say, can a TAP help with hydrogen as a fuel for CHP? But feel free, Bruce or Cliff, to address that.
Sure. Contact the TAPs. We are working on this. You know, it is a new piece of the energy puzzle. You know, when you do, you know, I guess the pun is intended. When you tap into one of the TAPs, we're a network of 10 TAPs. We also work with a number of the DOE consultants like Bruce and other program managers. So we will get the solutions to you. So the TAPs can, you know, are looking into hydrogen, and, you know, fuel cells are a CHP type of technology too. So I would say just contact one of your TAPs and we will get the resources to you.
Great. Okay. Well, thank you very much, Cliff. I think we're going to wrap it up now. Unfortunately, we got to cut it off there. But if you have any further questions, you know, feel free to email us at Better Buildings, and we'll try to direct your questions to the appropriate speaker. Just a quick, you know, update and reminder that this webinar is part of the 2021 Summer Webinar Series. We have a great lineup of presentations throughout the month of August. We encourage you to visit the Better Building Solutions Center to register for them. The next webinar that we'll have will be on energy service provider companies in the Express Lane, ESPC on the Express Lane on July 13th. This will officially launch DOE's E-Project Express, a new easy-to-use energy project tool tailored to states, local governments, and public institutions. And with that, I'd like to thank our panelists for taking the time to be with us today, and thank the audience for staying with us. And feel free to contact the presenters directly with additional questions if we couldn't get to it during the Q&A period. I also encourage you to follow Better Plants on Twitter and on LinkedIn to see all the latest news and updates about partners. And we'll see y'all in about 2 weeks.
Thanks, everyone. Appreciate your time.
Thank you.